Hello students, welcome to Kaur classes. Students, today we will discuss next assignment Physics 09 PHE-09 Optics. Let us start this assignment with question number 1 and part A. Light waves are propagating in vacuum. Derive the wave equation for associated magnetic field vector. On the basis of this equation, calculate speed of light. So the coupled electric and magnetic fields have to find out in the three-dimensional electromagnetic wave by using Maxwell fields. Here we have 1, 2, 3, 4 Maxwell field equations. Here the parameters: rho is free current density, J is conduction current density, E electric field, D electric displacement, and magnetic induction B, and magnetic field is H. The parameters can be used by and reduced in the D is equals to epsilon E, this is equation number 5th, B mu H, equation number 6th, and J is equals to sigma E, equation number 7th. Here epsilon is dielectric permittivity, mu is magnetic permeability, and sigma is the electrical conductivity. Here the equations 5th latest to last equations can be reduced to the formal equation by using equation number 8, 9, 10 and 11. We have these equations. Taking curl of equation number 10, we have equation number 12 by solve it, and here curly by curly is independent of the gradient operation, scalar operation. So simplify the left hand side of this equation. We have delta dot E is equals to 0. Then equation number 12 can be reduced. This equation can be reduced into minus gradient square E is equals to minus mu curly by curly T scalar product of with magnetic H value. On substituting the value in the equation number 11th, we have equation number 13th. Similarly, E, and this is the for magnetic field intensity, we have equation number 4th. Each component of E and H satisfy wave-like equation. So we can find out the velocity of the light, and by using the formula 1 upon root epsilon naught and mu naught. We have epsilon naught value 8.8542 into 10 raised to the power minus 12, and mu naught 4 pi into 10 raised to the power minus 7. We have just put these values and numerically find out approximate value 2.99, and approximate we can write it as 3.0 times per 8 meter per second, which is the equation of speed of the light. Next question is, what kind of polarized light will you get if two plane polarized light wave of equal amplitude but having a phase difference of 90 degree are superposed? Justify your answers and explain why unpolarized light reflected by a pile of plates is linearly polarized. Nature of the resultant wave arising due to the superposition of the two plane polarization waves. We have value E01, E02 and E0 are equal, but phases are differ by the 90 degree. So phase difference is equals to 2 and minus pi by 2, where n is equals to 0, plus minus 1, 2 and so on. Electric field vectors mutually perpendicular, so we can have two relations E1 and E2 in x-axis and y. For n is equals to 0, equation number 1 and 2 can be written by this, and resultant wave is equals to E1 plus E2. We have equation number 5. The scalar amplitude can be obtained from by combining the equation 1 and 2. We have the equation number 6, which is the equation of the circle. So phase difference is equals to 2 n plus pi by 2, with n is equals to various value 0, plus minus 1 by 2, plus minus 2, plus minus 1, plus minus 2 up to so on. So Ez can be written as the joining the equation number 1 and 2. So this shows that E vector rotates counterclockwise. So we have adding the equation number 6 and 7, we have equation number 8. Then this shows that this equation represents a linearly polarized light wave. Next question is, for normal incidence of light from a medium of refractive index 1.42 onto a medium of refractive index 1.64, calculate reflection and transmission coefficients. First of all, we have the given values n1 refractive index for incident light, and this is refractive index of medium n1 and n2. We have these values in the question given. Reflection coefficient for having formula R is equals to n1 minus n2 upon n1 plus n2 whole square. We have just put the values and find out the answer. Transmission coefficient have formula T is equals to n2 upon n1, 2n1 upon n1 plus n2 whole square. Just put the values and find out the answer. Next question is question number 2a part 1. Two light waves propagating in the same direction are superposed. The frequency of two light waves is the same and there is a constant phase difference between them. Obtain the expression for the intensity of the resulting wave. So we have the angular velocity, same angular velocity, but we have the values y1 and y2 having formula where delta is the a1 and a2, the amplitude, omega is the angular frequency. By using superposition principle, we have resultant displacement is equals to y, which is equals to y1 plus y2. We're just adding these values. We have y1 plus y2, and in this, for the simplification, just let a1 plus a2 cos delta is equals to a cos theta, where a is any constant, and a2 sin delta is equals to a sin theta. Just put the values in above equation. We have the equation number this, and this is the formula for a sin x plus y, omega t plus theta. So squaring and adding equation number 1 and 2, we have cos square plus sin square theta is equals to 1. We are left with value a square and having formula this, and intensity is equals to the square of the amplitude, which is equals to a square, and having this value. This is the resultant intensity. So it means that the I1 is proportional to A1 square and I2 is proportional to A2 square. And this equation can be also written as I1 plus I2 plus 2 I1 I2 root cos delta. So this equation shows the resultant intensity. Part 2 is the numerical. Two coherent sources of light having intensity ratio is given. Produces fringe pattern. Calculate ratio of intensity of bright and dark fringes. We have given I1 ratio I2 16 ratio 1. Bright light intensity is I1 plus I2 2 root I1 I2, and dark, here just put negative sign. We have given I1 upon I2 is equals to 16 ratio 1. By taking this root, we can have root of 16 is equals to 4, and use this formula in the given formula ratio. Just divide this both the equations, and here this is the formula. If we use here root I1 square plus root I2 square, this is a plus b whole square, and this is for formula becomes a minus 2 whole square. Just put these values from this relation, and we are left with 25 by 9, which is equals to 5 by 3 ratio, and this is the required answer what we have to calculate. For obtaining Newton's rings due to reflected light, convex lens is placed on a plain glass plate. So we have obtained expression for showing relation between radii of successive dark rings related to each other, and along with we have a numerical we will solve later. Consider a figure here. This is the lens. Just pausing the video, write this assumption and just a description of the diagram. Here the L dash is this is the lens which is placed on this glass plate AOB, and this is the equation, just diagram of a circle represents circle. So we have to use the property of a circle, which is equals to this part Pn square is equals to this distance into this whole distance. So we have used Pn square On into Ne. Put this value, Pn is equals to Rn. So Rn square On, this is the thickness T, and whole is R plus this R plus R. This is 2R and minus T. 2R minus T. We have put this value, and the T thickness is very very small as compared to the whole radius. So we just neglect this value T. So Rn square is equals to 2R capital T. Here 2t is equals to n lambda. So Rn square is proportional to n, and Rn is proportional to n root, where R2 and ratio R3 is equals to 1 ratio root 3 ratio and 3 root 3 and so on. The radius of dark ring is given by this formula. We use this formula for the numerical. We have to find radius of dark ring. It is given by the formula Rn is equals to n lambda r by mu root. Here n value is given 4 and lambda is given 589 nanometer. We will describe in the meter values, and mu value is given. Just put these values and find out the root. Please do it on yourself before note down this numerical, just to confirm the exact numerical value is direct match with this numerical value. So the diameter is equal, circle is equals to 2 into pi. Just use this value, and 2 into mu, sorry, this is the 2 into Rn. R here, not pi, this is Rn. Rn is equals to 1.12, and we have the answer 2.24 millimeter, or 2.24 into 10 to the power minus 3 meter. The question number 3C is the wedge shaped film has refractive index given, thickness is given, wavelength is also given, and we have to determine T. T is n lambda upon 2 mu, and we have value mu, lambda and n. Put this value and we have the thickness 1.83 to 10 to the power minus 6 meter, or 1.83 mu micrometer. The question number 3 part here is Fraunhofer diffraction is a special case of Fresnel diffraction. Explain and discuss also the concept of Fresnel half period elements. We have diagram in which this point is a focal point. This is origin source point from where the waves are propagating through the lens. This is a converging lens. The wave fronts are observed at the observation screen by passing through the diffraction screen. The screen is shown by what we observed in the screen is given by the diagram B. So here just description. Introducing a small modification in Cathwaite's experimental arrangement is given just before before the page. Formal page. The wavefront is now parallel to the diffracting screen with narrow opening in the form of long narrow slit by given figure B, and when incident wavefront is strictly parallel to the diffracting screen, the vertical path of light when the observed is immediately behind the aperture. And by pausing this video, you can note down these points related to the diagram. And along with this diffraction, with Fresnel diffraction, we have to discuss the concept of Fresnel half period elements. This is the diagram which shows that, and assume that light comes from infinity point, so that wavefront should be the plane. This is the plane W, W dash, F dash and F. This is the plane. We have comes the monochromatic light and form a wavefront, and the spectra we have observed. And to calculate resultant amplitude of the field, wavefronts should be divided into half period zones. That's why this concept is known as half period elements. And by pausing the video, you can note down the formula and points. And next question is, question number B is that discuss the dependence of image forming ability of an optical device on the phenomena of diffraction, and along with we have just calculate the numerical. The first point is image at a single point source. If we assume the geometrical optics, it is discussed that a well-corrected lens can produce a truly a point image with proper 100% accuracy, and by using this corrected lens, the image of distant star will have a sharp point like image. But this is only the approximation. Even corrected lens of a telescope cannot be give the image point image of a star, but it gives just bright circular disk. Neither the central disk nor the other fainter rings are sharply limited, and this angular radius can be used by the formula 1.22 lambda upon d. For small aperture sizes, the size of airy disk increases, but larger the aperture of the size, smaller is the airy disk. Image of two-point object in here is the given diagram. You can see the sizes of airy disk here are such that quite form apart from each other, and therefore they are seen distinctly as two patterns, but actually this is not as a two pattern. In other words, these two stars easily as shown as two when they are from apart from each other. So this for the we have also calculate to the numerical. Given is number of lines, resolving power 2000, and mean wavelength lambda is equals to 6 into 10 raised to minus 7 meter. We have to calculate delta lambda, having formula resolving power is equals to lambda upon delta lambda. So by resolving this formula, we can calculate delta lambda, which is equals to 3 into 10 raised to minus 10 meter or 3 angstrom. See, part of third question is grating has 10,000 lines per centimeter. Calculate maximum number of principal maxima that can be formed for light of wavelength 487 nanometer. So distance between slits is 1 in 10 to the minus 6 meter. So we have formula d n lambda is equals to d sine theta. Sine theta, because it is less than 1, so n d sine theta upon lambda is also less than equal to d by lambda. So n is less than equal to d by lambda. We can use equal to approximation, which is equals to 2.053, and accurate whole number is the 2. This is maximum number of principal maximal. Next, question number 4. What do you understand by temporal and spatial coherent of light? Is it true that observable interference fringe pattern cannot be obtained by using two incoherent sources in an interference experiment? Justify your answer. Temporal coherence is the it is a qualitatively calculated as interval of time during which the phase of the wave motion changes predictable manner, and it passes through a fixed point. It can be passes through a fixed point. This is axis between time. This is the change in the time between the two waves. And spatial coherence is the effect of this coherence understood by the source on interference of fringes, which have this diagram. In this diagram, to slit S1 and S2, it is extended with the light source S and S dash. This is extended. So if the source consisted of just a single point, the fringes of maximum visibility would have been observed. So if we consider the bright light and the dark fringes in the Young's experiment, so E1, E2 can be electric field associated with the light wave, and with the slit S1 and S2. So we have total resultant electric field is equals to E1 plus E2, and intensity average value of associated electric field, which is the intensity of light, is directly proportional to the E electric field. So from equation number 1 and 2, I is the summation of the resultant, means I square is equals to E square. E square is equals to E1 plus E2 whole square. E1 square plus E2 square plus 2 E1 E2. Here this is the formula of A plus B whole square. So E1 square is equals to I1, and E2 square can be written as I2, and this is as just written. And we have a result that E1 E2 should be equal to 0, because the product will be positive at one instant and negative at the other. So the product can be negative plus negative into positive value can be resulted to the 0, approximate 0. So the incoherent So the relationship can be set to coherent and resultant intensity is equals to the sum of the individual intensity of the slits. So question number B. Question number B is what condition must be met to obtain sustained stimulated emission? Compare and contrast 3-level and 4-level pumping schemes for a laser. Here first condition is if a material is found that could be induced to have a majority of atoms or ions in higher state than in the lower states. This means that if N2 is greater than N1, then stimulated emission may dominate absorption. But if B12 is equals to B21 in the formula, then this formula can be resolved by the question number 1. Here the Ignou is less than from KBT, and equation number 1 suggested simulation emission will dominate spontaneous emission. The 3-level pumping scheme in the first point is laser transition ends on the ground state and unpumped gain medium exhibits strong absorption on the laser transition, and the population inversion can be achieved by only pumping into higher level followed by a rapid radioactive or non-radioactive transfer into the upper level. So this is the ground lower laser and this is pumping state. This is just a few difference, and 4-level incident and then reflected in 1, 2 and 3 levels. This is total is 4-level pumping scheme, and 4-level these are the points according to the diagram. By pausing video you can note down these points. Last question of this assignment is an extended source of light whose linear dimension 0.3 mm in the Young's double slit experiment. Calculate maximum separation between the slits. If we have lambda given and this difference separation between the source and slit is also given. What we have in the numerical is y. Linear dimension of source of light y is equals to 0.3 into 10⁻³ meter. Lambda in meter. Separation is d, 0.5 meter. So maximum separation y is equals to lambda d upon d. By using this formula, we can calculate d value in the millimeter or meter also. So by doing these equations, we have completed the PHE-09 assignment. If you like this video, then please subscribe my channel, share and like it, and if any query regarding this assignment, just write in comment box. We are also available in Facebook, Instagram and Twitter. You can follow us for there, and along with this we are also available in WhatsApp group. The links of these sites are given in description. So along with this, if you require some other assignments, please write in comment box. Keep watching this channel. Thank you.